Welcome to G Fun Facts Online. Today, we're diving into a revolution that's quietly reshaping our world, from the cars we drive to the buildings we live in. It's called generative engineering, and it's all about turning artificial intelligence from a simple tool into a true creative partner. This isn't just a minor software update. It's a fundamental shift in how we create. Instead of a designer meticulously drawing every line and curve of a new product, they now act more like a creative director. They define the problem, set the goals, like this part needs to support X amount of weight, be as light as possible, and cost under Y dollars to make. And then the AI, our new creative partner, gets to work. It explores a vast universe of design possibilities, generating thousands of options, many of which a human designer might never have conceived. This leap from automation to co-creation is built on a fascinating history, starting with early computer-aided design, or CAD, back in the 1960s, with systems like Sketchpad. But today's technology is light years beyond that. So let's look at the AI powerhouse that makes this all possible. At the heart of generative engineering are several incredibly clever AI technologies. One of the most famous is the Generative Adversarial Network, or GAN. The easiest way to think of a GAN is to imagine a competition between an art forger and an art detective. The forger, which is one neural network called the generator, tries to create a fake design that looks completely real. The detective, another network called the discriminator, has been trained on real designs, and its job is to spot the fakes. They go back and forth, with the forger getting better at making fakes, and the detective getting better at spotting them. This continues until the generator becomes so skilled that its creations are indistinguishable from the real thing. At that point, it can be used to generate a flood of new, original, and inspiring concepts. Then we have variational autoencoders, or VAEs. Think of these as structured innovators, or maybe a design blender. A VAE can take two very different designs, say a sports car and a family sedan, and understand their fundamental properties. It can then generate a smooth spectrum of options between the two, creating a hybrid that has the sleek lines of the sports car but the practical space of the sedan. This allows designers to explore the in-between spaces of design in a very controlled way. Another key player is reinforcement learning. This is basically teaching an AI through trial and error, like training a pet with treats. In engineering, the AI agent makes a change to a design. If that change improves performance, for example, making a structure stronger or more aerodynamic, it receives a digital reward. The AI's goal is to maximize its total reward. It will relentlessly test modifications, learning what works and what doesn't, until it arrives at a design that is hyper-optimized for its specific task. Finally, there's a newer technology called transformers. These AI models revolutionized how computers understand human language by looking at the context and relationships between words in a sentence. Now, engineers are teaching them the language of design. By treating a design as a sequence of data points, a transformer can learn to generate new concepts or even predict how a design will perform without needing slow and expensive simulations. So, this all sounds very theoretical, but the real-world applications are where things get truly mind-blowing. The automotive industry was an early adopter, driven by the need for lighter, more efficient vehicles. Take Volkswagen, for example. They used generative design to reimagine the wheels for their electric microbus. The AI produced a set of wheels with an organic, almost twig-like appearance that were not only strong, but also 18% lighter. That's a significant weight saving that directly translates to longer battery range. Similarly, General Motors redesigned a simple seatbelt bracket. The original part was an assembly of multiple pieces. The AI generated a new, single-part design that was 40% lighter and 20% stronger. It's a small part, but when you multiply those savings across millions of vehicles, the impact on efficiency and cost is enormous. The aerospace industry, where every single gram matters, is a perfect fit for this technology. Airbus, in a landmark project, created what they call a bionic partition for their A320 aircraft. This is the wall separating the passenger cabin from the galley. The AI design algorithms mimic the way bone grows in nature, adding material only where strength is needed. The result was a partition that looks like a complex alien lattice structure and is an incredible 45% lighter than the traditional solid wall. Over the lifetime of an aircraft, that weight saving translates into huge fuel savings and a significant reduction in CO2 emissions. Generative Engineering even used this approach to improve NASA's life support backpacks for astronauts, achieving a part mass reduction of up to 50%, making spacewalks easier and launch costs lower. The world of architecture is also being transformed. In Amsterdam, a Dutch startup called MX3D collaborated with engineers to create the world's first 3D printed stainless steel bridge. This isn't just a simple slab of metal, it's a flowing, intricate, and organic form that spans a canal. The design was generated by AI and optimized for structural soundness and material efficiency, then fabricated layer by robotic arms. The bridge is even embedded with sensors, making it a living laboratory that collects data on its own performance. Even product design is seeing a wave of innovation. Under Armour partnered with Autodesk to create the UA Architect, a performance training shoe. Its most striking feature is the midsole, which is a complex 3D lattice. This structure was generatively designed to provide the perfect combination of stability and cushioning. It's a design that would be impossible to manufacture with traditional methods, showcasing the perfect synergy between generative design and 3D printing. Of course, a technology this powerful doesn't come without challenges. The software and the sheer computing power required can be very expensive, creating a barrier for smaller companies. There's also a growing skills gap. Designers and engineers now need to understand data science and how to collaborate with an AI, essentially learning to guide it towards the best solutions. Then there are the ethical considerations. AI models are trained on data, and if that data reflects our own societal biases, the AI will learn and perpetuate them. Imagine an AI trained only on designs made for men. It might consistently produce products that are ill-suited for women. This requires a conscious effort to create diverse and representative training data sets. And what about intellectual property? If an AI creates a brilliant, game-changing design, who owns the copyright? The programmer who built the AI? The designer who prompted it? Or the AI itself? Our current laws are built around the idea of human authorship and are struggling to keep up. The role of the human designer is evolving. They are shifting from being the sole creator to being a curator, a collaborator, and a guide for the AI. Their job is to ask the right questions, to sift through the thousands of AI-generated options to find the hidden gems, and to provide the critical feedback that steers the AI toward true innovation. Despite these challenges, the future is undeniably generative. We are heading towards an era where AI becomes an even more integrated partner. Imagine software that writes most of its own code, freeing up human engineers to focus on grander architectural challenges. We could see the democratization of design, where intuitive AI tools empower individuals and small businesses to create their own bespoke products and solutions. This isn't a story about machines replacing human creativity, it's about augmenting it. It's a new partnership, a co-creation between the human mind and artificial intelligence. Together, they have the potential to solve some of our biggest challenges, creating a world that is more sustainable, more efficient, and more beautiful than we can currently imagine. The creative partnership is just beginning, and the future it will forge is limited only by our imagination. That's all for this episode of Fun Facts Online. The next time you see a strangely shaped car part or an incredibly complex building, you might just be looking at the work of a human and their AI creative partner. Thanks for listening.